Hello students, welcome you once again to GK's maths classes. Today we are going to start a new chapter called Relations and Functions, which is CBSE class 12th, and this is the first video that we are putting on relations and functions. So today we will be discussing about relations and different types of relation, and if time permits we'll try to do few problems. Okay, I hope this will be useful to you, and in the subsequent videos definitely we'll discuss more in detail about problems related to relations and also start with functions. So kindly subscribe to my channel and also click the bell icon to get notifications of all videos, and thanks for the support that you have been rendering all this while. So let's continue with our video. Okay, let's start with the first problem. Now, first of all, before I go to relation, I would like to just go back to class 11th and revise few things so that things are clear, because it's a very difficult topic. You know, relations and functions is not an easy topic. It requires a lot of understanding. So for that, first what I will do, I will start, I assume that you know the definition of a set. I will first talk to you about cross product of a set. I will use Cartesian product of a set. This is all you have done in 11th standard. A cross B is defined as elements of the form A comma B such that the first element A belongs to A and B belongs to B. This is what you call cross product of two sets or Cartesian product of two sets, where A belongs to the first set and B belongs to the second set. And elements of A cross B will be of the form, it will be an ordered pair. Okay, so A comma B. Okay, now let us take one simple example. Suppose A is say 1, 2 and 3, and say B is A comma B. So how do I find A cross B? A cross B is 1 comma A, 1 comma B, 2 comma A, 2 comma B, then 3 comma A and 3 comma B. See, very simple. It's an ordered pair. Element from A, cross it with B. Now let us also try to find out what is B cross A is. B cross A is A comma 1, then you can do A comma 2, A comma 3, all of them separated by commas. And then B comma 1, B comma 2, and finally B comma 3. And clearly you can see that A cross B is definitely not equal to B cross A. But number of elements in A cross B will be same as number of element in B cross A, which can be calculated as number of element in A into number of element in B. So clearly in this case number of element in A cross B will be 6, because this is 3 elements, this is 2 elements, 3 into 2 is 6. And you can also find A cross A. I want to talk to you about that. A cross A also. How do I find A cross A? Take A with A again. So what do you get? 1 comma 1, 1 comma 2, 1 comma 3, 2 comma 1, 2 comma 2, 2 comma 3, 3 comma 1, 3 comma 2 and 3 comma 3. So this is how you get to, and you can see number of element in A cross A will be 3 into 3, which is 9 elements. Okay, so this is a basic definition that we have studied in class 11th. After defining a set, operations on set, you also have done A cross B. A cross B is element, it's an ordered pair, elements of the form A comma B, where the first element of the ordered pair belongs to the first set and the second element belongs to the second set. And we also understood that A cross B is not equal to B cross A, and number of element in A cross B will be equal to number of element in B cross A. So this is the first thing that you should know, because this is the basic. You should know what is A cross B before we talk about relations. Okay. Now that we have done with relation, defined now that we have defined what a A cross B is, now I'm going to talk about relation. R is a relation from A to B. I'm going to relate two sets. I have set A and I have set B. I'm going to relate them. R is a relation from A to B. Now what is the definition then? R is a relation from A to B, and it is said that is a relation. Then what does it mean? Then R will definitely be a subset of what? A cross B. You have studied this in 11th. R be a relation from A to B. When I say R is a relation from A to B, then R will be a subset of A cross B. R will be a subset of A cross B. Okay, I'll give you one simple example. If I take set A as 1, 2, 3, and if I take set B as 1, 3, 5, okay, I will find A cross B. What is A cross B? A cross B will be 1, 1, 1, 3, 1, 5, 2, 1, 2, 3, 2, 5, 3, 1, 3, 3, and 3, 5. This is A cross B. Now R is a relation from A to B. Now how do I define this relation? R such that ordered pair A comma B such that A equal to B, where A belongs to A and B belongs to B. Look at this relation. So what all will R contain? All elements where A and B are equal. So which are the elements that are equal here? You have 1, 1, then you have 3, 3. This is one relation. Now where is this? It is an A cross B. That is why we say a relation is always a subset of A cross B. Do not forget this. A relation from A to B will always be a subset of A cross B. A relation R from A to B will be a subset of A cross B. And the elements in the relation will be an ordered pair. Because it is a subset of A cross B, elements in A cross B is an ordered pair. So all elements in the relation should be an ordered pair, because again I'm repeating, a relation from A to B is a subset of A cross B. Okay. Now is this the only relation possible? You can define many relations. Now how do I find the number of relations? Now suppose let us assume A is a set which has P elements and B is a set which has Q elements. It has Q number of elements. A has P elements, B has Q elements. So how many elements will A cross B will have? The number of element in A cross B will be number of element in A into number of element in B. Correct? Now, what are the number of subsets? Number of subsets of A cross B. The number of subsets of A cross B will be 2 power PQ. You know this formula. If a set has n elements, the number of subsets will be 2 power n. So if A cross B has PQ elements, the number of subset of A cross B will be 2 power PQ. And what is the relation? A relation R from A to B is all possible subsets of A cross B. Correct? Therefore, the number of relation R from A to B will be 2 to the power of number of element in A into number of element in B. What is that? In this case, it is 2 power PQ. So the number of relations R from A to B will be a subset of A cross B. Number of relation R from A to B will be 2 to the power of number of element in A into number of element in B. Very important formula. You will be getting this detail for 1 mark. If possible, 1 mark question. Now there's another term, another usage of words that you should know. Sometimes they will say R is a relation on A. Now what does it mean? When I say R is a relation on A, When I say R is a relation on A, it is understood that R is a relation from A to A. Otherwise, I will definitely say R is a relation from A to B. If I don't say A to B and if I say R is a relation on A, it is assumed that R is a relation from taking set A to set A. You are relating set A with set A. Okay? And obviously, by this definition, R will be a subset of what? Will be a subset of A cross A. R will be a subset of A cross A. Now, let us assume the number of elements in A as say P. So, how many elements will be there in A cross A? Will be P square, correct? Therefore, the number of relations are on A will be 2 to the power of P square. Another very important formula that you should know for 1 mark question. Okay, so what did we do till now? I talked to you about A cross B and I showed you that A cross B and B cross A are not same, and I also told you how to find number of element in A cross B, and if R is a relation from A to B, then R is a subset of A cross B. So elements of R should be an ordered pair because it is a subset of A cross B. And I also told you how many relations can be defined from A to B. Number of relations R from A to B will be the number of subsets of A cross B, which is nothing but 2 power number of elements in A into number of elements in B. Suppose A and B, if the relation is not from A to B, it is from A to A, I will say it as R is a relation on A and R will be a subset of A cross A. And I also spoke to you about number of relations R on A will be 2 power P into P, that is P square. I hope this is clear. This is what you must have studied in class 11th. So I have just revised with you what the 11th standard portion of relation is. Now we are going to move forward and do different types of relation. Now what are the various types of relations that we want to know? The first type of relation is called, first of all let me define, let S be a non-empty set. So what is the meaning of non-empty set? Non-empty set means it should have at least one element. Non-empty set means it should have at least one element. Okay, S be a non-empty set and R is a relation on S. R is a, or I'll change this to A so we are comfortable with A. R is a relation on A. That means what? That is R is from where to where? From A to A. That is what? R is a subset of A cross A. From the definition, A is a non-empty set, R is a relation on A, so R will be a subset of A cross A. Now, there are different types of relation. The first type of relation is called reflexive relation. So what is a reflexive relation? In reflexive relation, this means for every or for all. The symbol is for all, or you can say for every. For all elements A belongs to capital A. For all elements A belongs to capital A. For all elements A belongs to capital A. If A is related to itself, if A is related to itself, A comma A belongs to R, then I can say R is reflexive. I'll take one simple example. Let us take one simple example. Let my set A be set of straight lines in a plane. Okay, set of straight lines in a plane. I define the relation R on A. How do I define? R equal to line 1 comma line 2 such that line 1 is parallel to line 2. This is my definition. Now, let us check whether it is reflexive or not. For every line 1 in the set A, or every line 1 in set A, every line is parallel to itself. Yes or no? Every line is parallel to itself. So from this, can I say that L1 comma L1 belongs to A? Therefore, in this case, R is reflexive. So for this example, R is reflexive. I hope this is clear. I'll give you one example which is not reflexive, then you'll understand. And this is another example to make you understand it's not reflexive. Let A be set of natural numbers. Natural numbers. I'm just taking some example. You can take any example you want. I define my relation R on A. Now how do I define it? I define it as A comma B such that A is less than B. Such that A is less than B. Now for reflexive, what I do? I choose an element A belongs to A. I choose one element. I choose a natural number. Can any natural number be less than itself? Not possible. Therefore, A comma A does not belong to R. Therefore, R is not reflexive. I hope this example should make you understand what is a reflexive relation, and you also understand an example of a reflexive relation and example of a relation which is not reflexive. Okay, maybe I'll take one more example. Let A be set of straight lines in a plane. I define my relation R on A. How do I define? R equal to A L1 comma L2 such that L1 is perpendicular to L2. Now see, if I choose L1 belongs to A, every line is not perpendicular to itself. They are not perpendicular. L1 cannot be perpendicular to itself. So L1 comma L1 does not belong to R. Therefore, R is not reflexive. Now, if I want to make this reflexive, all that I need to do is add one equal to sign. A less than or equal to B, if I put, it will become reflexive because A equal to B will work. Okay. So I gave you an example of a relation which is reflexive. I gave you two examples of a relation which are not reflexive. So in reflexive, what happens? All elements of A should be related to its all elements. Even if one element is not related, it is not reflexive. So all the elements, that is why I said for all the elements of A should be related to itself. If it is not related to itself, it cannot be reflexive. Are you clear with the reflexive relation? Now let's go to I think I'll go to the last page. I need some space. Okay, let's come back to this. Now I'll talk about the next relation called symmetric. Now how do I deal with symmetric relation? In reflexive, I chose one element, but all the elements. Okay, I chose one element, but I chose all the elements. Here I will be choosing two elements. What are they? For every A comma B belongs to set A. There I chose one element. What is that? A belongs to A. Now there is no initial condition. If A is related to itself, it's reflexive. But whereas here what happens? You have a condition. What is the condition? If A is related to B, if this is true, if A is related to B, then you must have B is related to A. You must have B is related to A. In that case, you can say R is symmetric. Now let's take some example. Let's take the same example which I did in the previous problem, where A is set of all straight lines. I'm not writing that, you can refer back, where I define the relation as L1 comma L2 such that L1 is parallel to L2. Correct? Now let's talk about symmetric. for every L1 comma L2 belongs to set A, if, I told you, that's the initial condition, if L1 and L2 are parallel, that is L1 is parallel to L2, this is given. If this is given, obviously L2 will be parallel to L1, correct? Then you can say L2 comma L1 belongs to R. This shows that R is symmetric. So this is an example of a relation which is symmetric. And you also know this relation was reflexive. It was also reflexive. Now you have proved it is symmetric. Now let's take the second example which I gave you. What is that example? Set of all natural numbers, and I define the relation as A comma B such that a relation R from A comma B such that A is less than B. Now, for every A comma B belongs to set A, that is natural numbers, if A is related to B, A is related to B, that means what? A is definitely less than B. If it is true, then but B cannot be less than A, correct? No? 1 is less than 2, 2 cannot be less than 1, correct? So B comma A does not belong to R. This implies R is not symmetric. So you have given an example of a relation which is reflexive and symmetric, and I gave you another example which is not reflexive and not symmetric. Okay, let's go to one more example. Let me take the same example. What is that? Set of all straight line in a plane, and I define the relation R as L1 comma L2 such that L1 is perpendicular to L2. Now for every L1 and L2 belongs to the set A, if L1 comma L2 belongs to R, that means what? L1 is perpendicular to L2. You know this. This implies L2 will also be perpendicular to L1. If line 1 is perpendicular to line 2, you can say line 2 is perpendicular to line 1. So clearly L2 comma L1 also belongs to R. So this is R is symmetric. But you know this was not reflexive. So you have an example where it is reflexive and symmetric. You have an example where it was not reflexive, not symmetric. You have an example where it is not reflexive but symmetric. So what is the condition? For reflexive, for every A, it should be related to itself. For symmetric, if A is related to B, if that condition is true, then B also should be related to A. Then you can say it is symmetric. I hope these examples are clear to understand what is a symmetric relation is. Now let's go to transitive, the last one. Transitive relation. So what is a transitive relation? In reflexive, you chose one element. In symmetric, you chose two elements. But in transitive, you will be choosing three elements. What are they? For every A comma B comma C belongs to the set A, and it has two conditions. In reflexive, there is no condition. In symmetric, you have one condition. What is that? A is related to B. That must be true. But in transitive, you must have two conditions which is true. What is that? If this is true, if A comma B belongs to R and B comma C also belongs to R, if these two are true, then you can say, then you should have A comma C belongs to R. This shows that R is transitive. If A is related to B and B is related to C, if both are true, you can have A is related to C. If these three are true, then you can say the relation is transitive. Now let's go to that example which we have. Take set of all straight lines, okay, and I will take the relation as L1 comma L2 such that L1 is parallel to L2. I'll take the same example to make you understand things. So how many lines I should choose? I should choose 3 lines. Where do they belong to? They belong to the set A. So that is the first condition. What is that? L1 comma L2 belongs to R, and L2 comma L3 belongs to R. These two are true. That means what? L1 is parallel to L2 and L2 is parallel to L3. So clearly you can see that L1 by geometry, L1 is parallel to L3. This implies L1 comma L3 belongs to R. So this is an example of a relation which is reflexive, which is symmetric, and it is also transitive. Okay. Now let's look at this another example. Set of all natural numbers, and I define the relation as A comma B such that A is less than B. If A comma B belongs to R and B comma C also belongs to R, this implies what? A is less than B and B is less than C. So clearly you can see A is definitely less than C. This implies A comma C definitely belongs to R. This implies R is transitive. So this is a wonderful example where the relation is not reflexive, not symmetric, but only transitive. Okay, very beautiful example. Now let us take the other example like L1 comma L2, where L1 is perpendicular to L2. Now for every L1 comma L2 comma L3 belongs to A, if this is true, what is that? L1 comma L2 belongs to R and L2 comma L3 belongs to R. That means what? L1 is perpendicular to L2 and L2 is perpendicular to L3. See this? L1 is perpendicular to L2, correct? And L2 is perpendicular to L3. So L1 and L3 are not perpendicular. They are not perpendicular, correct? So this implies L1 comma L3 does not belong to R. Therefore, R is not transitive. So I gave you an example of relations which is transitive. I gave you an example of relation which is not transitive. Always we should have examples which negates. Okay. If I want to know reflexive, I should know what is an example which is not reflexive. If I know an example for symmetric, I should know an example for not symmetric. If I know an example for transitive, I should know an example for not transitive. That makes me to understand reflexive, symmetric and transitive better. Okay. And if a relation, if a relation R is reflexive, symmetric and transitive, if it is all three, then we say R is an equivalence relation. What type of relation? R is an equivalence relation. If the relation is reflexive, symmetric and transitive, all three are satisfied. Now look at this. This is an example of a relation which is reflexive, symmetric and transitive. Therefore, this is an equivalence relation. Whereas this was not reflexive, it was not symmetric, it's only transitive. So it is not an equivalence relation. This is an example which is not reflexive but symmetric, not transitive. It is not an equivalence relation. If you want a relation to be an equivalence relation, it has to be reflexive, symmetric and transitive. Very, very simple. Okay. So this is the basic, this is the definitions that you should definitely know if you want to get inside a problem. If you want to solve a problem in reflexive, symmetric and transitive, you should know the definition. Now I'm going to slightly modify my definition of transitive. One more definition, okay? It's a very weird definition, but you should know. And I will write it in red color. This is something very, very important. For every A comma B belongs to A, this is also a definition, okay? If A comma B belongs to R and I don't have B comma C belonging to R, I don't have. I know only A comma B belongs to R. I don't have A comma C belongs to R. I don't have, this is not available, okay? This is not to be seen. Only if this is there, I can talk about A comma C. If it is not there, if I have only A comma B belongs to R, you can say the relation is transitive. The relation is transitive. If you have only A comma B, relation is transitive. So please make a note of this, very, very important. Okay, this is the correct definition. This is also a property to understand why it is transitive. If you don't have this B comma C, only if these two are true, this is true. If only this is true, and that is the condition for transitive. Okay, so it's difficult to comprehend, but you have to accept it. Okay, I hope it's clear to you what is reflexive, symmetric, and transitive is. Okay, let us. And I also want to talk to you about something else, which I will do it in the next video. There's something called, I'll just mention it, something called equivalence class. Very, very important. Okay, what is an equivalence class? Now, what is equivalence class? The definition and an example, we'll do it in the next video, so that you also understand what it is. So it's a lengthy problem. I will take a problem and try to find the equivalence class for you. Okay. So now what we'll do, we'll just try to solve one question. Okay. Or which one? Okay, let me take this simple question. This is an NCERT question. So I will solve one problem and leave. Rest of the things we'll do it in the next video. Show that the relation R in a set A of points in a plane. The points are not in space, but it is in a plane. Given by the relation R equal to P comma Q, how is the relation defined? R equal to 2 points P comma Q such that OP equal to OQ. Its distance from the origin is same. I have to check whether it is an equivalence relation or not. Now, how do I choose? First, I have to verify what relation. I have to verify reflexive. Now, how do I verify reflexive? How many points I should choose? I should choose only one. For every P belongs to, what is my set? My set is A. You know very well, OP is equal to OP, correct? OP equal to OP. This implies the point P is related to itself, correct? I am using the definition. This implies R is reflexive. Is that clear? Now let's go to symmetric. How many elements I should choose? For every P comma Q belongs to A, set A, definitely this must be true. What is that? P comma Q should definitely belongs to R. Definitely P comma Q should belong to R. That means what? That means by the definition, OP equal to OQ. If OP equal to OQ, what do you know? OQ equal to OP. If OQ equal to OP, what do you know? Q comma P belongs to R. So this implies R is what type of relation? R is a symmetric relation. Clear? Now let's go to the last one, transitive. Transitive. How many elements I choose? I choose 3 elements. P, Q and S belongs to set A. If there are 2 conditions, if P comma Q belongs to R and Q comma S belongs to R, what does it mean? This means OP equal to OQ and OQ equal to OS. This implies from the definition, from the 2 equations, OP equal to OS. This implies P is related to S, correct? P is related to S. So what type of relation is R? R is transitive. Since R is reflexive, symmetric and transitive, R is what type of relation? It's an equivalence relation. That is the first part of the question. Okay, I have proved that it is an equivalence relation. Now what is the next part I want to prove? Further show that set of all points P not equal to 0. So let me choose a point P which is not 0. Since it is not origin, I will definitely have an origin. I call it as O, okay, and I will say this is a fixed point. I am not going to change this point or move this point, okay. I want to take set of all points, so let an arbitrary point be Q. Q is any point. So any point means it's a variable, okay. It will move. How does it move? OQ should be equal to OP. It will move in such a way that OQ equal to OP. So when Q takes different positions, okay, when Q takes different positions, what will happen? These are the various positions of Q. When Q takes different position, the path of Q, or you can use the word locus. Locus means path. The path of Q is a circle. Where does the circle pass through? Passing through P with O origin as center and radius OP, which is nothing but an equivalence class. So, what is the equivalence class? We need to have a separate class for that. Okay, we'll do that separately. So that proves the second part of the question. Further show that set of all points. Here the set of all points is Q. Okay, passing through P. So I see set of all points passes through P with origin as center and radius OP. Okay, I hope this is clear to you. We will, next video, which is part 2, we will be doing only problems related to relations and functions. We will do around a lot of questions are there. Not only NCERT questions, we will also do questions from outside which has come in the board exam, which are very, very important. Today I thought I will just introduce you to this topic, and just for an example I have solved one problem. I hope it was very useful to you. So kindly subscribe to my channel and also click the bell icon to get notifications of all videos that we post. And thank you for the support, whatever you have done till now. I hope to meet you again in the next video. Have a nice day. Bye-bye.